All right. Welcome everyone to tonight's class. Today we're talking about a new topic, which is quite very interesting. It's one of the most interesting topic in mathematics, and you would see why I said so as we move through tonight's class. This is quite very simple, and I would really love you to pay real attention so that you can get the best from the class. I'll be giving you the distinction between permutation and combination, and we'll be solving several questions on both permutation and combination. And also, we would at some point solve questions relating to both permutation and combination. That means we're going to have a question that embodies permutation and also combination. It's a very simple topic in mathematics. I would really love you to pay real attention. So I want to welcome you once again to tonight's class. All right. So the class is starting right now. All right. Let's talk about permutation. What is the meaning of permutation? For those of you not familiar with this topic at all, you don't need to worry at all. We're going to lay it out from scratch. So what is the meaning of permutation? What is the meaning of combination? Well, permutation is associated with arranging things in different order. Permutation is associated with, look at the first word, a very important word, arranging. Permutation has to do with arranging things in different order. The second keyword, order. These are keywords under permutation that you need to never forget. The most important one here is the word arranging. So when you see the word permutation, or when you see the word arranging being used in a question, you need to understand that that is referring to permutation. Now, generally in mathematics, we define permutation with the use of P. So you would see something like NPR, for instance. This means N permutation R. Now, what does this all mean, and why does all this matter? You see, this N here has to do with the whole object, the whole number of objects. For instance, let's say I have this letter A, B, C, D. Let's take this for instance. We have A, B, C, D. You see right here that we have 4 objects in general. That means in this case, our N here is what? 4. Now, what does R stands for? R is what we use to denote the number of objects you want to arrange out of this total of 4. That means, for instance, someone may ask you to arrange, this is 4 objects, A, B, C, and D. Somebody may ask you to arrange the whole 4. In that case, that means I will be saying 4. Now, if I'm going to be mathematical, I will say 4 permutation 4. But if I want to be a bit casual,
I can actually say 4, arranging 4. Now, that means I could also decide, or someone could also ask me to arrange 3 out of this 4, because that's possible also. I may decide that, okay, I don't want the whole 4 to be arranged. I just want 3 out of these 4 objects. In that case, that means I'll be saying 4 arranging 3. I prefer to use the word arranging so that you can easily relate to it. Now look at another possibility. It's possible that someone says, okay, I don't want you to arrange 4 objects out of this possible 4. I want you to arrange just 2. In that case, that means I'll be saying 4 arranging 2. All right? Also, it's still possible that someone says, I want you to just arrange 1 out of this object. In that case, we'll say 4 arranging 1, and we can also have 4 arranging 0. Now, I'm going to explain, and you're going to understand this topic very, very smoothly because it's quite very interesting. So, once again, one of the things you can take out from everything I just said is the use of the word permutation can also be synonymous with the word arranging. Now, I told you that permutation is associated with arranging things in a different order. That it would be good for you to take that in your notes. It's associated with arranging things in a different order. Let me explain that part. In a different order. When you talk about permutation, let's assume I wanted to arrange just AB. Let me use AB now. I'm sure you agree with me that AB, I can also decide that I don't want it to be AB, I want to make it BA. One thing I want you to note here is that this is a permutation. This is another permutation. When I use the word this is a permutation, I hope you're not confused with the word this is a permutation. I could also say this is an arrangement. And also this is another arrangement. For instance, let's take for instance that these 2A and B represents people sitting in a particular row. Let's say, for instance, A represented Abraham and B represented Bayo. I hope you know that if I tell Abraham to sit first and Bayo sit second, I hope you know that's an arrangement that is totally different from me saying Bayo should sit first and Abraham should sit second. So this is an arrangement. This is one arrangement. This is another arrangement. That means if I have 2 objects, AB, I could actually arrange AB in 2 different ways. That means I can arrange it as AB or arrange it as BA. So if they tell me now to answer this question, look at the question. In how many ways can you arrange the letter AB? Of course, the answer will be very simple. 2 ways, as you can see. Except if you are right there still thinking of a different arrangement which I have not talked about, which obviously I'm sure you all agree that there is no other arrangement possible for AB. It is either AB or BA. So we can arrange this in actually 2 ways. That will be your answer. And this can be arranged in 2 ways. All right, this is simple. Let's go into a much more technical aspect. Let's use ABC now. So let's say we are no longer dealing with AB now. We're dealing with ABC. Now we are having Abraham, Bayo, and Caroline. How many ways can we arrange ABC? Let's assume you are asked to answer that question. Now, before I go into the technical mathematical way of solving this, let me give you the general hang around this. You have ABC. How many ways can you arrange ABC? Now, you will all agree with me that, of course, the first possibility will be ABC. But I hope you know that it's possible for me to also have ACB. That means now Abraham was number 1, Caroline was number 2, Bayo was number 3. That's also a different arrangement. Now, I'm sure you agree with me that I could have BAC. And I'm sure you agree with me that I could also have BCA. All right? Now, is that all? Not exactly. I believe you agree with me that I can also have CAB. You can see what I'm doing here. And I can also have CBA. Now, if you're right there and you can see any other way that I have not included here, please signify quickly. But to the best of my knowledge, I believe that these are the all possibilities of arranging A, B, C. These are the, now, if you count these different arrangements, how many ways can I arrange A, B, C? It will be 1, 2, 3, 4, 5, 6. The answer right there is 6 ways. All right. Now, this is us doing it the manual way. Now, look at something. For those of you trying to understand how I was able to bring out all these arrangements, it's so simple. I held A, I had B and C. So I held A still, I interchanged C and B. Now I brought B as number 1, I had A and C. I held B also, I interchanged C and A. Now I had C, I held C, I had A and B, then I interchanged it. That was the way I was able to bring it out easily and completely. All right, good. Now, I believe everyone following can easily relate to what's going on here now. That when we have objects, by the way, we use the word object majorly when we're dealing with permutation and combination. Try and fix your mind more on objects. Not, I know I used Abraham, Bayo, Caroline, but look at every different thing as objects. So that means in this case, I had 3 objects. Objects could be people, could be books, could be animal, could be anything. So use the word more of objects when dealing with permutation and combination. So now you can see how I was able to arrange 2 objects. Now, but let me bring a possibility here. I want you to know that this is me having 3 objects and I was arranging the 3 of them. You can see I had 3 objects. I was arranging the 3 of them. Guys, it is possible for me to have these same 3 objects and I'm only arranging 2 of them. You see, when I use the word P, it's permutation I'm writing, but I'm using the word arrangement so that you get very familiar with the word permutation, arranging. So now, it's possible I have 3 objects and I'm arranging 2 out of the 3. That means I'm not supposed to arrange the whole 3. So let's see what are the possibilities under arranging just 2. Look at it. I could have AB. I could also have AC. All right. I could have BA. I could have CA. I want you to know that these are all arrangements. This is an arrangement. This is an arrangement. This is also an arrangement. Me interchanging B and A. And this is also another arrangement. Now, is this all of the arrangement we can get? No. I could have what else? What else could I? Is there any other thing I can have? Okay, it looks like this is everything. No, not actually. I can have BC and I can have CB. Is there anybody there that can bring out any other permutation that I'm yet to bring out? Now, if you ask me now that in how many ways can I arrange 3 objects, can I arrange 2 objects out of a possible 3? That's 3 arranging 2. Of course, this is one way. I'm arranging only 2 out of them. That means out of these 3 objects, I'm only picking 2. So in this case now, I'm picking just A and B. Of course, that's part of the, that's okay. Now I'm having A and C in this second one. That's also okay. Of course, as long as I don't use the whole 3. Now I picked only B and A here. That's also okay because it's not yet It has not been, this is not part of it. Then I have CA. It's also a possibility. I have BC and I have CB. So obviously, when you do the sum of this is 6 ways also. So that means 3 permutation 2 is 6. You can confirm all this in your calculator. We'll get to that very soon, how to use your calculator to check this. Now, I want you to have proper understanding of this, because having proper understanding will help you to solve technical questions. And let me tell you guys quickly, there are lots of technical questions. This is probably one of the most juicy parts for technical questions. In some cases, you will see questions where you probably will not even be able to identify that are being asked permutation and combination. It's that very examinable. Now, let's move on, guys. You know, I've been spending more of my time talking about permutation. And if you notice what has been happening, when we deal with permutation, we're dealing with arrangement. And if you notice, AB was an arrangement, BA was also an arrangement. So you can see now that when we're dealing with permutation, we are not concerned about the fact that AB exists, and we're saying, but this is still the same objects being used. No, AB was used here, BA was used here. There are 2 different arrangements. Note that, all right? Now, what do we do when dealing with combination? Because I want to juxtapose this with the use of the word permutation and combination. What is combination? I told you already that permutation, this is everything we've been saying now is permutation. What is combination? Combination is concerned about combining things. If you're taking a note, please write that down. Combination is concerned about combining things. That means under combination, we are trying to combine things together. And under combination, let me say one thing quickly. This is 1, 2, 3, 4, 5, 6 different permutations. Again, when I use the word permutation, please always remember I'm also talking about arrangement. 1, 2, 3, 4, 5, 6 arrangement or permutation. Good. But let me tell you guys, if I was going to talk about combination, this is just one combination. Because under combination, we're not concerned about arranging things. We're concerned about combining things. And this is one combination. This is a repetition, because under combination, all we are concerned about is that we have combined certain things together. We're not concerned about arrangement or order, how things went. No, we're not concerned about that. Under combination, all we're desirous of is, do we have these 3 things together? Yes, we have it together. So you see here, this is ABC. Okay, what about this one? Oh, this is still ABC. Since if we're dealing with combination, this is still the same thing as this, because this is the same combination. This is the same coming together. This is the same team as this one. It's like saying you made a team of Abraham, Bayo, and Caroline. You said this is a team. You said, okay, good. Then I said, bring me another team. And Abraham, Caroline, and Bayo came. I said, what are you guys doing? This is the same thing you just showed me earlier. Of course, I'm sure you can relate to what I'm saying. Under combination, it's just combining things. And I said, give me another team. And Caroline comes, Abraham comes, Bayo comes. I said, this is still the same combination. Because what matters is, have you combined these things together? Once you have combined them together and they are the same thing is recalling again, you cannot count that as a different combination. All this is one combination. 6 permutation, one combination. Look at the one we have right here, AB, BA. This is 2 permutation. Again, you can use the word, this is 2 arrangement. But this is just one combination. Because if I say, give me a team, and Abraham and Bayo runs outside and say, sir, I'm here. Okay, I said, nice, I have this team, a team that where Abraham is present, Bayo is present. I then go on and say, give me a different team. And then Bayo comes, I say, okay, let me see the next person that comes. Abraham comes. If Abraham and Bayo are still the same people in that team, I will tell them that no, this is not what I want. I want a different team. Now, guys, note, it is okay if it was Abraham and someone else, as long as it wasn't Bayo again. That's a different team. That what I'm saying here is that Abraham and Bayo is a team. Abraham and Caroline is another team. Bayo and Caroline is another team. Abraham, or which other one can we have? Okay, these are three different teams. So this can be seen as like three combination now. But if I had maybe Bayo BA, I would never count this because this is already here. This team already occurred already. Now, if I had CA, I would not count this as another combination because this has occurred here already. These two are the same team. If I have, I cannot count CB also because BC already occurred. This is under combination. So under combination, you deal with combining things. Under permutation, you deal with arranging things in order. So under permutation, we have this arrangement, this arrangement, this arrangement, this arrangement, this arrangement, this arrangement, and they are all 6 different arrangements. That means I can arrange ABC in 6 different ways. That's proper. But if I say, how many ways can I combine ABC? You can only combine ABC in one way. One way, that's only one way. ABC is, all these ones are all one combination. That is the differences. If you are asked to differentiate between permutation and combination, that is the major difference. Permutation is more concerned with arranging things in different orders, while combination is concerned about combining things. All right. Now, I believe if you have been following this class, you can really now relate to what permutation and combination really entails. But there's so much more that you are yet to know. And that's why let's move on. Now, I told you already that lots of technical questions exist under this topic, and that's why the basics are very important to be established. Now, let's try and talk about the mathematical way of solving permutation and combination, because it's not every question you would see that you will be able to solve using these ways that we have been doing. You don't actually have to solve ABC. How many ways can you arrange ABC? Imagine that was a question. You don't have to be doing this. There are mathematical way, a very simple formula to get your answer quickly. But this is for you to understand what's going on so that you will not ever go wrong when you are given a much more technical question. Now look at something here. This is the formula for when you have n permutation R. It is equals to n factorial over n minus R factorial. This is the formula. Maybe I should write it right here. N permutation R is equals to n factorial over n minus R factorial. I'm sure you all know what factorial really means. When you're dealing with factorial, for instance, if I have 5 factorial, 5 factorial implies that this is 5 factorial. 5 times 4 times 3 times 2 times 1. More like, if you can notice what is happening here, look at it. It's more like I had 5 times 5 minus 1 times 5 minus 2 times 5 minus 3 times what? 5 minus what? 4. Okay, I want to take you a bit technical. Please pay attention and don't lose your focus. I want to say something that will make you so grounded in permutation and combination that you will never be able to be confused. Now, somebody saw me doing something now, and probably the person was wondering, sir, why did you stop at 1? Are you not supposed to write times 0? Oh, let me tell you what actually happens here. It was, if you look at something, I hope you can understand what I just did right here. What I did right here was 5 times 5 minus 1. That means I was subtracting 1, and then I was moving it in a descending order. So 5 times 4, 4 is 5 minus 1, 3 is 5 minus 2, 2 is 5 minus 3, and 1 is 5 minus 4. Now, you know that instead of writing 5 factorial, I can decide to write it as 5 times 4 factorial. Just a little brief on how you should understand these things. This 5 factorial is the same thing as 5 times 4 factorial. You say, what am I talking about? If I told you 5 factorial was you moving in descending order, don't you see that 5 times 4 factorial will be the same thing as 5 times... Now, what is 4 factorial? 4 factorial will be 4 times 3 times 2 times 1. You can see exactly what's going on there. So you need to understand all these things so that you will be able to crack any question easily. So if I ask you to write 7 factorial, you can easily write 7 factorial as 7 times 6. Of course, you could take it to the last value 1, or you can decide to just shoot it as, stop it here. You're still correct. That means you can go on to write 7 times 6 times 5 factorial. You're still correct. Because obviously 5 factorial will move from 5 up to 1. Someone else may decide not to stop it at 5 factorial. You may decide to stop it at maybe times 4 times 3 factorial. Now, somebody is asking me, sir, what is the essence of me stopping at 3 factorial or stopping at 4 factorial? The point is, there are many times when you stopping at a certain point will help you to do your arithmetic much easily. So you need to learn all these tricks, all these skills, so that you will be able to easily solve questions around permutation. Now, look at what we have here. Never forget this. N permutation R is equals to n factorial over n minus r factorial. Good. Note that we're going to use it in a few minutes now. Let me write that of combination. So what is... We wrote 6 ways here. Let me still write it because we're going to solve this using the calculations. If I have n combination R, of course, you should be able to relate to what combination is because we used combination under binomial expansion. So n combination R, that means we are forming a team. We have n objects and we are forming a team of R. So it's possible you have 3 objects and you are asked to form only 2. We get to combination sooner, of course, most likely not in this class, but just hold on tight. We're going to explain deeply what combination means. This is just introductory classes. But what is the formula for combination? Combination is equals to n factorial over n minus r factorial, r factorial. Can you see that? Spot the difference between the formula for both n permutation r and n combination r. The difference is this r factorial. So this and this are very much alike, only that that of combination has r factorial added to it. So you should not mix things up together. Now let's use, because we are majoring on our permutation for tonight, let's use this formula to solve all these questions we have solved before. Now, without using the formula, we were asked to arrange these 2 objects. That how many ways can we arrange these 2 objects? Of course, that means, look at it. Look at that question. In how many ways can we arrange 2 objects? How do you answer questions like that? In how many ways can you arrange 2 objects? You have 2 objects. Of course, when you see a question like that, that means they actually need to arrange everything. In how many ways can you arrange 2 objects? That's 2 arranging 2. All right? 2 arranging 2. 2, you are arranging 2. Now, let's use this understanding now with our formula and let's see what we're going to get. That means we have 2 permutation 2. Applying this formula, this will be 2 factorial over 2 minus 2 factorial. I'm sure you should be able to relate to what I just did because our n here was 2, our how here was 2. If you fix this into this formula, that will be 2 factorial over 2 minus 2 factorial. This is going to give us something that you would really love. This will be equals to 2 factorial over 2 minus 2 is what? 0 factorial. Now, this gives me an opportunity to explain this to you. What is 0 factorial? What is 0 factorial? Now, because I don't want to take you on a different pathway, I want you to still focus on what we're doing. I would prove 0 factorial being equals to 1 in another class. But just for the sake of this class, always remember that 0 factorial is equals to 1. 0 factorial equals to 1. That means this will be 2 factorial over 1. What is 2 factorial? 2 factorial is 2 times 1 over 1. That means the total, the number of ways is actually what? 2. Now, let's go back to our original expression. Oh, somebody said I should prove it now. If I prove it now, you know what? You give me about 10 minutes so that I can ensure you guys are drenched in this knowledge. I don't like to get things very confusing because some people are still trying to conceive this. All right. So that's the reason why I may want to be calm about that. But it's quite very simple. It's and very logical and very easy to understand. So now, just for those of you following, understand that before we did this, use this formula, we used our manual method to get the number of ways by saying we had 2 objects. We want to arrange the 2 objects. We can have AB or we can have BA. We said 2 ways. Now we made use of the formula and look at it right here. We got the same answer, 2. So that is established. You can see that the formula works very well. Let's try. Okay, it looks like a lot of people are talking about proving it. We're going to prove it any seconds from now. Just hold on. Let me. It looks like, why are you guys very interested in proving 0 factorial? It's very interesting, but I will do it. Don't worry. I'm going to do it in this class since there is a lot of interest in it. Now we have 3 permutation 3. Can you guys quickly use this formula to get the answer? Now, don't forget we used the manual method. We got six ways. So go on to use this formula and let's see what the answer will be. So it's quite very interesting. Okay, I like that. Please ensure you are working with me. I would be very much happy to see that you are getting the best from this class. Now, this is just introduction. We have, look at it. We have so much to do. This is 3 permutation 3. When we are having 3 objects and we have to arrange the 3 of them. Of course, don't forget we could be told to arrange just 2. But if you are told, for instance, let me tell you how the question could come. In how many ways can you arrange ABC? That means you are asked to arrange the whole of ABC. Of course, in how many ways can you arrange it? That will be 3, arranging the 3. Now, but you could be told that in how many ways can you arrange 2 out of the alphabet ABC? That case, your answer, your solutions will be towards 3, arranging just 2 out of it. So, of course, 3 permutation 3 will be 3 factorial over 3 minus 3 factorial, which will be 3 factorial over 0 factorial. That will be 3 factorial over 1. That will be 3 times 2 times 1 over 1, because 3 factorial is 3 times 2 times 1 over 1. That will be 6. All right, that is established. I believe you guys are flowing well with that. Good. This also gives me, you can see 0 factorial being 1. So we're going to do that very soon. All right. Now, let me do the last one here just to establish that this formula works. 3 permutation 2. Imagine you are told to arrange just 2 out of 3 objects. 3 arranging 2. Using the formula, this will be equals to 3 factorial over 3 minus 2 factorial. So that will be 3 factorial over 1 factorial. This will be 3 times 2 times 1 over 1. This will be 6. Can you see we got the same answer? Good. This is how you understand permutation properly. It has to do with arrangement. And once you see question that has to do with arrangement, because it's not every time they will tell you using, maybe they may not use the word permutation. You may see things like, in how many ways can you arrange? Once you see that, understand this is a permutation question. All right. Now, those of you that are interested in understanding how 0 factorial is 1, let's get right into it. So quickly, can you write 5 factorial? Please, I would like you to use your calculator here because we may not be able to pick up. But of course, just go on to write 5 factorial and write the answer. What is 5 factorial? Five factorial is what? Five factorial is 120. Good. That's good. 120. Go on to write 4 factorial. What is 4 factorial? Okay, somebody said 24. Okay, somebody said 60. Okay, actually 4 factorial is 24. You can use your calculator here. If you don't, you can just, if you don't know how to do it quickly, you can just do 4 times 3 times 2 if you want to do that, but you can use your calculator. Now you can guess the next thing I'm going to ask for. That'll be 3 factorial. What's 3 factorial? 3 factorial is what? 6. Thank you. I like that. Now, what do you feel I'm going to ask next? I'm going to ask about 2 factorial, right? What is 2 factorial? 2 factorial is what? 2. So I'm going to stop here. Then I want to establish a logical understanding. Now pay real attention. You will see something that is going on here. I'm sure you guys did quantitative reasoning when you were younger. So you would see how this thing is moving, and then you'll be able to infer the next one. Now do something right here. This is 120. This is 24. Go on and say, what is 120 divided by 24? If you find out what's going on here, you will see that 120 divided by 5 gave you 24. Let me just quickly, 120, thank you. I like the answers I'm seeing. 120 divided by 5 gave you 24. Now, 24, 120 divided by 5 give you 24. 24 divided by 4 will give you 6. Just follow the pattern and you understand what's going on. 24 divided by 4 gives you 6. All right? Good. Now, this is 5. This is 4. What do you think is going to be the next thing I'm going to ask for? Of course, 3. 5, 4, 3. So 6 divided by 3, of course, it gave me 2. So are you seeing the pattern already going on? Good. So you don't need to ask me already. You know if I don't do any other thing. I'm sure you know the next thing according to this pattern will be 5, 4, 3. The next one is supposed to be 2. The next one is supposed to be what? 1. I'm sure you know that's logical to assume. Good. Thank you for knowing that. Now let's try and continue our factorial. So if we have 1 factorial, I don't want to use the answer you know already. I don't want to use the answer you know already. I want to use this my logical pattern going on. So I have 5, 4, 3. So that means the next one I'll be saying 2 divided by what? 5, 4, 3. I'll write 2. 2 divided by 2 will give me what? 1. Am I correct? That's the pattern. Follow the pattern, you understand what's going on. Now, I don't need to, the next one, this is 5, 4, 3, 2. The next one will be 1. Yeah. So for me to get my 0 factorial now, 0 factorial, it will be 1, of course, divided by 1. What's 1 divided by 1? 1. Good. That's it. So you can see that 0 factorial is 1. All right. Does it make sense? You see how interesting it is. So that's really great. You people should be giving me a round of applause. All right. You guys should be celebrating me right now. Anyway, that's nice. And thank you for asking me to do it because I wanted to push it forward, but it looks like it was good that it was done now. All right. Great. So now let's try and now start cracking some bones under permutation, because now is the time for you to really brace up, because lots of questions are coming. Look at this first question we want to answer now. This is the first question we want to answer. In how many different ways can you arrange 3 books on a shelf from a group of 7? In how many different ways? In how many different ways in how many different ways can you arrange 3 books? Three books on a shelf. So you have a shelf and you are told to arrange 3 books on the shelf, but you are actually having you're having a total of 7 books. So in how many different ways can you arrange 3 books on a shelf from a group of 7? Now, I'm going to teach you 2 different ways of solving this. I already explained one to you already, because you know, in this case now, guys, look at something going on here. I want you to please be very attentive here, because at this point now, you need to really focus. Now, they said in how many different ways can you arrange 3 books on a shelf from a group of 7? This is the reason why I had to teach you that formula. That's the M permutation R, because look at this right now. We have 7 objects. We are told to arrange just 3 of them. If you don't know how to apply the formula, you will be, just think about it. Imagine, let's use the books as A, B, C, D, E, F, G. Imagine this is 1, 2, 3, 4, 5, 6, 7. Imagine these are the books, book A, book B. Imagine these are the 7 books. You're not told to arrange 3 books out of this. Do you know how hard it's going to be? And almost impossible for you to be going on to be saying, I can have an arrangement of A, B, C, A, C, D, D, E, F, A, F, G. You know, you get yourself into a quagmire. It's going to be very, very impossible to do. And that's the reason why you needed to know the formula. So instead of you going through all those, all you need to do is to just apply 7. You have 7 books, but you are only told to arrange 3. So obviously that will be 7 permutation 3, which will be equals to 7 factorial over 7 minus 3 factorial. This will be 7 factorial over 4 factorial. Now pay attention to why I taught you a way of solving factorial. Now, if you go on and you are pressing 7 factorial in your calculator and then you're trying to divide it by 4 factorial, that will be tedious to do. Easily, you could just do this. Look at what you could just do. You can write 7 times 6 times 5 times 4 factorial. You see what I just did right there? I stopped at 4 factorial. You say, why did I stop at 4 factorial? Deliberately, because I saw that there was a denominator of 4 factorial. And I know that if I stopped at 4 factorial, I can easily cancel this out. Are you seeing how I've made my work very easy? Right? So now I have cancelled that out. So my answer will be 7 times 6 times 5. Of course, this is 7 times 30. And this is 210. So that means we can arrange 7 books. Sorry, we can arrange 3 books from a group of 7 in 210 ways. All right? That's how simple permutation and combination is. Once you are following me, please, you can't go wrong, I can assure you. Make sure you just maintain the momentum. Now, I want to teach you another way of solving this without following the formula. I'm sure everybody could relate to the formula method. Let me teach you another way of solving this. This one is much more, it's also very nice and neat also, depending on how you love your understanding. Now look at something going on, guys. Look at a more practical way of solving this. In how many different ways can I arrange 3 books from a group of 7? Look at what I'm going to do. I'm going to put like a placement for the 3 books. Now I'm going to arrange just 3 books. I have 1, 2, 3 books. Look at that. This is the first book, second book, the third book. Because I'm only interested in arranging 3 books. So look at what I made the space for just 3 books. Now, look at what's going on here. This first book, let's say, imagine this was a shelf. Imagine this was a shelf. Probably I'm a very poor artist. I think so. But imagine this was a shelf. And I had only 3 space for 3 books. Let's say book 1 was taking this first space, book 2 was taking the second space, and book 3 was taking this third space. Right? Now, imagine we were asked to arrange this first space. Guys, please pay attention. You will get what I want to say next. Now, you have 7 books. Let's assume, let me try and assume we have, let me bring all the books here. I want you guys to get the introductory part properly so that we don't, look at now, we have 7 books. 1, 2, 3, 4, 5, 6, 7. We want to fill the first spot, guys. How many possibilities do I have to fill this first spot? Can somebody please answer that quickly? How many possibilities of book do I have that I can use to fill this first spot? Well, in case you are following me, you would see that I have 7 books at my disposal. That means I can decide to pick this first one to fill this place. I can decide to pick this number 5 to fill this place. I can decide to pick number 6 to fill this place. I can decide to pick number 7 to fill this place, and so on and so forth. So that means I can fill this first space with 7 books. 7 books are at my disposal. 7 books. I have 7 books at my disposal. I have 7 books. Let me write it here also so that you can understand what's going on. 7 books are at my disposal. Now, guys, please pay attention. Now, I have filled the first space, obviously with just 1 book. Out of these 7, I picked 1. I'm not talking, I don't know which one. I'm not talking about the one. Let's say I just picked 1. Let's say I picked number 3 now, for instance. I picked book 3. I have filled it here. Guys, this second space on the shelf, how many ways can I fill this second space? How many books at my disposal will I be having to be able to fill this second space? How many books at my disposal will I have to fill this second space? Of course, the answer is 6, because I already used 7. I already used 1, sorry, for my first space. So let's say I pick book 3 now. Of course, I cannot pick book 3 again. You know that already, because I've already dropped book 3 on the first space. So obviously, I can only fill the second space with only a possibility of 6 books at my disposal. All right. Now, the last, because don't forget, we only have 3 spaces we are trying to fill. The last space we are trying to fill now. How many books? How many books do I have at my disposal for this last column? How many books do I have at my disposal at this last spot? Look at the first space. I had 7 books that I could use. That's it, written there, 7. Since I have filled the first space, I want to fill the second space. I only had 6 at my disposal. Now I have filled this first space. I've filled the second space. How many books will I have for the third space? Of course, the answer is 5. If I have filled this place with a possibility of 7, of course, if I have dropped 1 book here, I'm only left with 6. So 7, 6, 5. Now look at it. Multiply these things together. What does it give you? 210. That's a way of answering this question without wasting time. All you need to do is to just say, I have 3 slots. How many ways can I fill the first slot? 7 ways. How many ways can I fill the second slot after I filled the first one? 6 ways. How many ways can I fill the third slot after I filled the first and the second? 5 ways. Multiply them together, you get 210. Right? That's how beautiful this is. Now, I want to ask this question I want you to solve on your own. In how many different ways can we arrange 5 books on a shelf? That's all I'm going to say. That's the question. In how many different ways can you arrange 5 books on a shelf? That's the question now. In how many different ways can you arrange? This is another question we are solving already. In how many different ways can you arrange 5 books on a shelf? So let me get your answers. In how many different ways? I'm going to use this question to explain something very, very vital, extremely vital under permutation. I'm begging you, please, if you are in this class, please pay attention. These are the basics that establishes your root in permutation and combination. Once you are good in these basics, you would not go wrong. Now, I saw different answers already. Somebody said 120. Somebody said, okay, I like what I saw somebody do now. Good. Now, this is what I like. I love that person that wrote 5 times 4 times 3 times 2 times 1. That person understood the last thing I just said, which is very vital. Good. I like that. Now, I'm going to use 3 different methods to solve this. Don't forget, the last question I used only 2. But because of the peculiarity of this question, I'm going to use 3 different methods. Please be very versatile in the 3. The reason for that is because there are some questions that you may need. I repeat, this last example I just saw, that last method I used, there are some examples that you would need to understand that method of solving. So I did not tell you that you should discard the second method I saw, that it's optional. Please learn that second method, because there are some questions, I repeat, that you would need that logic to be able to solve it. Now, I'm going to also give you a third way that is peculiar to this particular question. Now, let's solve this question together. I'll use 3 different methods to solve it. Probably I'll divide this into 3. The first way will be the formula way. The first way will be the formula way. The formula way. That means in this case, I'm using n permutation r. In how many different ways can you arrange 5 books on a shelf? 5 books. That means I have 5 books on a shelf. In this case, I want you to understand that nobody is asking me to arrange sum of these books. They just said, in how many ways can I arrange these 5 books? So that means what I'll be solving will be 5. I'm arranging the whole 5. Nobody told me to select 4 out of them or select 3. I'm arranging the whole 5. So 5, I'm arranging the whole 5. So solving this using your formula, this will be 5 factorial over 5 minus 5 factorial, which will be 5 factorial over 0 factorial, which is 5 factorial over 1, which is 5 times 4 times 3 times 2 times 1 over 1, which is what? 20 times 6. That's what? 120 ways. Now, we have gotten that using the formula method. Good. That's established. But let's use the second method we used in the last example. In how many different ways can I arrange 5 books on a shelf? You know what you're going to do? Draw the space for 5 objects, because 5 objects is what we actually want to arrange. We want to arrange 5 objects, right? Good. This first space, guys, I have 5 books now in my hand. I want to drop these on a shelf. 5 books in my hand, I want to drop on a shelf. The first spot on the shelf, I'm holding the 5 books. What's my option to fill in this first spot, guys? What's my option to fill in this first spot? What's my option? I have this space. This is the space on the shelf now. I want to fill 5 books here. This first space, what's the option I have? Of course, I have 5 because I'm holding all the 5 books. So that very first space, I can pick any of those 5 books. So I'm going to write 5 there. Good. Thank you for all the answers I'm getting. I love those answers. Now for the second spot now, since I have filled the first spot, what's going to be the options I will have for the second spot? For the second spot, what's the options I have? Of course, I have filled this place with 1. So all the books I'm having now that I have filled the first space will only be 4. So this can only happen in 4 ways. I can only fill this second spot in 4 ways. Either I use book 1, or I use book 2, or I use book 3, or I use book 4. So this can be filled in 4 ways. Now, let's say I'm done filling the first, I'm done filling the second. Now, how many ways will I be able to fill this third place? Of course, only 3, because I'll be left with 3 books in my hand. So I can only fill this in 3 ways. All right. Now, I'm done filling the first, the second, the third. How many ways will I be able to fill this fourth? Of course, 2 ways, because I will be left with only 2 books in my hand when I'm filling this place. Only 2 books will be left. And if I have filled first, second, third, and fourth, to fill this last spot, I will only be left with 1 book at that point, because I have filled this, I have filled this, I have filled this. So this last spot will be able to be filled in just 1 way. And how you do this is to just say 5 times 4 times 3 times 2 times 1. That will give you 120 ways. You can see how beautiful that is, right? That's beautiful. Good. Now, the last way to solve questions like this, please pay attention. This is very vital to note. Guys, this is something, a concept I want to introduce in case you don't know it. Please pay attention. When you have a situation when you are arranging every of the objects you are given, that means you are arranging, for instance, you had 4 objects, you are arranging the whole 4. Or for instance, you had 10 objects, you are arranging the whole 10. So if you are arranging n objects, considering n of them at a time, that means when you are having a case of n, you are arranging the whole of the n. Guys, listen attentively. If you are having n objects and you are arranging the whole n, which is a case like this, because you had 5 books, you are arranging the whole 5 books. whenever you have something like this, it is always equals to n factorial. Do you get that? Whenever you are arranging the whole of the object, please remember n arranging n is the same thing as n factorial. Anywhere, anytime, if you once you detect that you're told to arrange every of this object, please, you don't need to go on doing all this. This is good. I had to do it so that you guys can flow. But once you know that I'm arranging everything, just go on to do n factorial. That means in a case like this, since I'm having 5 objects, I'm arranging 5. This will be 5 factorial. All right. That means this will be 5 times 4 times 3 times 2 times 1, which is 120 ways. The basics are the most important part of any topic. Please ensure you are having great notes. I would really love you to take this question and quickly answer it quickly. And I'll be very happy to see you excel in it. Can you find the number of permutation of the letter of the word cano? Find the number of permutation. This is a question I want you to answer. Find the number of permutation. Find the number of permutation. Please take good notes. Find the number of permutation of the letter of the word cano. All right, so I saw some of you talking about the timing. For today's class, of course, I would not be getting to the maximal 2 hours, but you need to prepare for that because I just want to introduce you to these topics today. So don't worry, I will not be getting to the 2 hours today, but somebody talked about we talking about 1 hour class. That was for calculus, all right? That was for calculus. So, and now that we're not engaging in calculus, it's a different thing because we're trying to establish the basics of this topic. So, guys, make sure you prepare for us solving very, very extensively because we need to really understand this topic. Now you have the letter of the word cano. Now find the number of permutation. Do I have great answers there? Okay, so people are saying 24. Are they correct? Find the number of permutation. Now I told you already that when you see the word permutation, what should come to your mind? Arrangement. It's more like saying find the number of arrangements of the word cano. Find the number of arrangements of the word cano. How can I arrange the word cano? Of course, that I can see cano has how many objects? Please, I told you already using the word object. This is 1 object, 2 object, 3 object, 4 objects. That's 4 objects, 4 distinct objects. Now, I have 4 objects. I want to find number of ways I can arrange the word cano. Just so you understand what they're asking you to do. It's more like saying K-A-N-O, K-N-A-O, K-A-O-N, and so on and so forth. You know what I'm talking about. That's what they're asking you. So we don't need to always do this. Let's just use our formula. That's 4 arranging 4 because we're arranging all the letters. We're not told to arrange some or not. We're arranging all of them. So obviously 4 arranging 4. I told you already when you have a situation like this where you're arranging everything, you don't need to go on to stress yourself. Just use 4 factorial. That will be 4 times 3 times 2 times 1. That will be what? 24 ways. So 24 arrangements. You know, let's follow the context of the question. My number of permutation, 24 arrangements. or we can even say 24 permutation. That's actually better because that was how the question stated it. So 24 permutations. It looks like you guys are enjoying yourself permutating that. Well, now I'm going to see who is going to get this question. This question, of course, we'll keep, you know how we're supposed to do it. We'll keep moving a bit into technical questions. Now, find the number of ways first, second, third can be taken by 10 number of students in a class. Find the number of ways, find the number of ways that first, this position, first, second, of course, and third can be taken. That means we have 10 students, can be taken by 10 number of students. In a class. Right? Find the number of ways first, second, and third can be taken by 10 number of students in a class. So you understand this kind of, that means you have 10 people in a class. How many ways can the position first, second, third comes? Has anybody got an answer to this? Wow, I love what I'm seeing. It looks like you guys are so, like, you're so great. That's so good. I like that. Now, number of ways first, second, third. For those of you that you're not yet probably understanding what's going on, we have first, second, third. First, second, third. The number of ways first, second, third can be taken by 10 number of students. First, second, third. If I wanted to even use that my other formula, first, second, third, I would say, obviously, the first position, if I have 10 number of students, let's say there are 10 students staying here. If I want to fix the number of people that can take first when is actually 10. Then if somebody has taken first, you will be left with only 9 people that can take second. And if you are done with first and second, you are only left to take people that can take third. And that's what you're interested in. So that will be obviously 10 times 9 times 8, which is what? 720. Now another way of doing this will be using the formula. That means we have 10 people. You want to arrange just 3 of them. You're arranging just 3 of them. That's the meaning of this. You have 10 people, you're arranging just 3. Because first, second, third is a position for just 3 people. So 10 permutation 3, which will be obviously 10 factorial over 10 minus 3 factorial. And that will be 10 factorial over 7 factorial. I told you how to solve this. This will be 10 times 9 times 8 times 7 factorial. You stop at 7 factorial because I can see 7 factorial is as the denominator. So I cancel this. That will be 10 times 9 times 8. That will be 720 ways. And you see how beautiful permutation is, right? Now, take this question down very quickly. 12 skiers. I hope you know what skiers are. Of course, that's a sport. Skiers. Twelve skiers. So 12 skiers are competing in the final round of the Olympic freestyle skiing area competition. So 12 skiers are competing. Please take good notes. In the final round of the Olympic freestyle area competition. Now, this is the question. In how many different ways can the skiers finish the competition, assuming there are no ties? In how many different ways? In how many different ways can the skiers finish the competition? Of course, we are assuming that there are no ties. I'm sure you understand what ties means. That means we don't have somebody being first and another person being the same first. So the question is, you have 12 skiers. They are competing in the final round of the Olympic freestyle area competition. In how many different ways can the skiers finish the competition? How many different ways can these skiers finish the competition? Do we have answers? Whoops. Looks like it's a very big result. Just just write it technically. You don't have to write the final answer. Let me know you know what you're doing. Okay, good. I like that. Okay, this is nice. This is nice. So look at it. 12 skiers are competing in the final round of the Olympic freestyle competition. We have 12 skiers. I told you already that when you have all these skiers, people, books, always see them as objects. So we have 12 objects here. In how many different ways can the skiers finish the competition? That means, what are different ways you can arrange these objects, these 12 objects? That's the meaning of this second question. The meaning of finish competition, that means how many different ways you can have first, second, third, fourth, fifth, up to 12th, assuming there are no ties. Now, if you wanted to do this very easily, just go on to say you have 12 objects, you are arranging the whole 12 because you are not told to not probably arrange just 10. No, you are arranging the whole 12. So this obviously is the same thing as 12 factorial. If you want to use the second method, of course, what you want to do is just to go on to say, let me give positions for all the 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a very simple way of doing it also. And then you can go on and say the first place can be occupied by 12 people initially. And then if you have, of course, if somebody is already there, the next will be occupied by 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. You understand what's going on there? Of course, that's still 12 factorial, but that's another way of understanding. Now, what's question number B? Question number B said, in how many different ways can 3 of these skiers finish first, second, and third to win the gold, silver, and bronze medal? In how many different ways can 3 of the skiers finish first, second, and third to win the gold, silver, and bronze medal? In how many different ways can 3 of the skiers finish first, second, and third to win the gold, silver, and bronze medal? Do we have answers? Oh, somebody said 120, somebody said 1320. Okay. In how many different ways can 3 of these skiers finish Can three of the skiers finish first, second, third to win gold, silver, and bronze medal? Of course, when they said in how many different ways now, you have 12 skiers. In how many different ways now can these 12 skiers finish, three of them, just three of them now, finish first, second, third? That means in this case now, you're not concerned about everybody, you're concerned about three of them. That means you are only concerned about you're having 12 skiers, you are arranging just three out of them because you are interested in just the first, second, and third. That'll be 12 arranging three. So you, of course, this will be 12 factorial over 12 minus 3 factorial, which will be 12 factorial over 9 factorial. And of course, you know how to do this. This will be 12 times 11 times 10 times 9 factorial. Stop it at 9 factorial. You know why already. So we're having 12 times 11 times 10. That'll be 1320 ways. That's how beautiful this is. That's how beautiful this is. You don't have to. I told you already. This is a very interesting topic. But although I will warn you, you have to keep following because there are technical questions. It's actually one of the fact that it's quite very simple makes it very easy to also examine you effectively. Under permutation, we still have more things to talk about. But because this is the introductory class and I would love you to, I just want us to get, let's start softly, but please tomorrow, this is where I want us to end the class, by the way. Tomorrow we would delve very, very deeper. There's still so much to talk about. And I can assure you, the way you enjoyed this, the way you loved, you were able to understand, that's the same way you would be able to understand till the end if you pay attention. Now, our classes will continue tomorrow and we'll keep having it. For now, we are moving into permutation and combination. We'll be going deeper, deeper. Please do not miss any of these classes. It's extremely important so you can have your, you can have, are you guys saying you want us to continue? Is that a consensus or are you saying you want us to continue? Please let's continue tomorrow because I want you to have, of course, this is the introductory class. So please, tomorrow, what we'll be discussing is, this is introduction. So you see how we're able to introduce ourselves, familiarize ourselves with permutation. We've not done so much of combination, but now I believe you can now differentiate between the two. And now we are not leaving permutation tomorrow. I believe the whole of tomorrow's class will still be on permutation. You will now see technical questions, all right? Technical questions. There are technical questions in permutation. I'm sure if I give it right now, many of you will not be able to solve it. But of course, I understand that. So what I would say is let's be here tomorrow, same time, same venue. Ensure that you are prepared and please ensure you come on time so that we can start immediately. So we have so much to talk about. We want to talk about indistinguishable object. We want to talk about permutation with condition. We want to talk about cyclic permutation and every other thing in between. We want to talk about equation involving permutation. Then if we have time, we can go into combination. If not, we'll move it to the other class. So guys, this was really great. I love that you guys were really, really interactive. I love the fact that you were giving me answers. It was quite very nice. That's how it should be. So please ensure we do it the same way tomorrow. Save the time and be on time. Thank you guys. Thank you guys so much for joining. We'll see tomorrow. Take care of yourself.